Hey everybody, it's Mr. N, and let's see if we can solve each of these for x. So on this first one, what we have here is these two angles in a triangle, and then we've got this external angle. So what we need to know is a theorem that the external angle is equal to the sum of these two remote interior angles. So we can say 2x plus 53 equals the 40 plus the 3x. So the external equals the sum of these two remote interior angles. So now we can simply solve for x by subtracting 2x from each side, and we'll get 53 equals 40 minus x, plus x, and then we're going to subtract 40 from each side, so we'll get x equals 13. All right, so for this next one, let's take a look at what we have. We've got this triangle, we've got one big triangle there, we've got this triangle in here and that triangle. Now, based on what I see from these angles, it looks like all three angles here are congruent. So we've got an equilateral triangle in here, and then we've got an isosceles triangle over here. Now, that tells me that since this is equilateral, all these are going to be 10. But also, since this is isosceles right here, by the isosceles triangle theorem, it's actually the converse of it, we know that these two angles are congruent, so these two sides will be congruent. So that means this side, which is the 10, will be the same as the x plus 2. So we can simply set them equal to each other, so x plus 2 would be that 10, so x equals 8. All right, so let's take a look at this last one. We are told that ABC is similar to DEF, so these two triangles are similar. So that means they will have sides that are in proportion, and most notably, it'll be AB to DF. So, I'm sorry, AB to DE. So there's DE, there's AB. So I know that I will have these two sides in proportion. X will be proportional to 50. Now, if we have a scale factor of A to B, or we have sides that are in a ratio of A to B, in order to get the area, we would have to square the scale factor, so it would be a squared to b squared. So we need to square this scale factor to get the ratio of the areas. Well, the ratio of the smaller triangle, that area came out to be 100, and the larger one was 2,500. So now we end up with x squared over 2,500 because I squared 50, so 50 times 50 gave me the 2,500 equals 100 over 2,500 as well. So now you can cross multiply to solve these if you would like and solve for x. Remember, you'll have to take the square root of it, or you could just take a look at it. So I can here, since these two are equivalent down on the bottom, that would mean x squared would have to be 100, so that means x would be 10. We would say plus or minus 10, but since we're dealing with side lengths, we're just going to keep the positive value only. All right, so I know that was a quick little video, but these are some common geometric concepts that are good to know. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.